Hi everyone, this is BB Sangme, and in this video I am going to discuss about the design of knuckle joint part 2. In this portion I am going to discuss about the empirical relations and design of eye and fork, whether the design is safe for eye and fork or not. Okay, so do watch the complete video of part 1 and part 2 for the understanding of design of knuckle joint. Okay, so do subscribe for the latest videos of machine design. So let us see the second part of design of knuckle joint. So this is the figure. In the previous video I have discussed regarding the every dimensions of dimension of this figure. Okay, so once in the previous video we have discussed regarding the design of pin. We can calculate the diameter of pin by considering the failure of pin in shear, and also we can calculate the diameter of pin by considering the failure of pin in bending. We have to select the diameter of pin which is the maximum among that. Okay, and after the selection of diameter of pin, that is small d, we have to check for the stresses induced in the eye and induced stresses induced in the fork. Okay, so once you will calculate the diameter of pin, next is the time to now we need to calculate the dimensions of fork and eye. Okay, so the dimensions of eye means we need to calculate the inside diameter, outside diameter and thickness. Obviously inside diameter is nothing but the it is the diameter of pin, which is already calculated in the previous video. We have seen how to calculate the diameter of pin. Okay, once you will calculate the diameter of pin, you can calculate the outside diameter, you can calculate the thickness. Okay, so let us discuss about the thickness of eye and fork. So here you can see that A is the thickness of fork, which is equals to 0.75 into capital D, where capital D is the diameter of rod. So in the first step, in the first video, I have discussed regarding how to calculate the diameter of rod. Once you will calculate the diameter of rod, put the value of diameter of rod here, you will get the value of A, that is thickness of fork, and B is the thickness of eye. So this is the thickness of eye. Here you can see that B is nothing but it is 1.25 into D, where D is the diameter of rod. Okay, so once you will calculate the diameter of rod, you can calculate the thickness of eye and thickness of fork and thickness of eye. Okay, there is one more empirical relation between the outer diameter and the diameter of pin. So outer diameter of eye and fork. So this is the circular portion which represents the outer diameter of eye. This is the outer diameter of eye, and this is the outer diameter of fork. It is represented by DO, small d. So there is a relation between diameter of pin and DO. Diameter of pin is small d. So here you can see that the outer diameter is 2 times the diameter of pin. So in the previous video we have discussed regarding the how to calculate the diameter of pin. Once you will calculate the diameter of pin, you can calculate the outer diameter. Okay, so outer diameter is 2 times the diameter of pin. Next is the diameter of pin head, D1. Okay, so the diameter of pin head is, as per empirical relation, it is 1.5 times the diameter of pin. Okay, and next is the gap X, which is standard gap, which is 10 mm. Here you can see the gap X. Okay, so these are the empirical relations. These values can be calculated after the calculation of diameter of rod and diameter of pin. These are totally related with the dimensions of outer diameter of eye and fork. It is related with the diameter of pin. Okay, and the thickness of eye and fork, it is related with diameter of rod. Okay, now once you will calculate the thickness of fork and eye, diameter of outer and inner diameter of fork and eye, we need to check the stresses induced in the eye and fork. So let us discuss about that. So first is the tensile failure of eye. Here there is the section XX. I have highlighted the section already. Okay, so at this section, when you will apply the force of magnitude, tensile force of magnitude P, there is a possibility of failure of eye. Here you can see the eye, the failure of eye. Okay, so we need to calculate the area under tension. Okay, so this is the area under tension. So here the area is we need to consider the thickness of eye, which is B, and we need to consider the outer and inner diameter. Already in the previous slide I have explained how to calculate the outer and inner diameter. Outer diameter is 2 times the diameter of pin, and inner diameter is nothing but the diameter of pin. Okay, So by using this formula we can calculate the area under tension. So this is the area under tension, this is the rectangular area, you can see that this is the width and this is nothing but the do minus d area. Okay, so area is b, a is equals to b into bracket do minus d. So the induced tensile stress sigma t is equals to p by a. We have to just put the value of a area in this equation. It will be sigma t is equals to p into bracket b into sigma t is equals to p into p divided by b into bracket do minus d. Okay, so similarly for the we have to consider the shear failure of I. Okay, so in this here you can see that in this diagram I have highlighted this portion. After the application of force there is a possibility of shear failure, so this portion of I can get separated, it will tear off because of the application of force. So I have calculated the approximate area at here. So the outer diameter is do minus inner diameter d, so you will get this portion, this is do minus d, and the thickness portion b. Okay, this is the thickness and this is the do minus d portion. Okay, sorry, do by 2 minus d by 2. Okay, so here do by 2 minus d by 2 is the area for single shear. If you consider the area at the upper portion, here you can see that there is a double shear. Shear will happen at shear will take place at this plane and this plane also. So there is a double shear. For the single shear, area will be a is equals to b by 2 do minus d, and for the double shear the formula will be 2a is equals to b into do minus d. Okay, so here the induced shear stress is tau is equals to p divided by 2a. Here area is multiplied by 2 because double shear takes place at here. Okay, so the formula will be tau is equals to p divided by 2 into bracket b into do minus d divided by 2. Okay, so 2 will get cancelled. The formula will be tau is equals to p divided by b into do minus d. So you have to put the value of b, you have to put the value of do and d and p, then you will get the value of tau, and you have to check whether the induced shear stress is less than the permissible one or not. If it is less than the permissible shear stress, then the design is safe. If the induced shear stress tau for the given dimensions, for the calculated dimensions of the I, if the induced shear stress will be greater than the permissible one, then the design is not safe. Okay, next is tensile failure of fork. Already we have seen the tensile failure of I. So in case of fork, here you can see that after the application of force, okay, there is a possibility of failure of fork at this portion. When you will apply a force of magnitude P, the possibility of failure of the fork will fail at here in tensile manner. Okay, so we need to calculate this area. This area is actually it is 2a into do minus d, where a is the thickness of one eye. Here I have considered the 2a because there are two eyes for the fork. Okay, so this a and this a, these are the two thicknesses multiplied by do minus d. Okay, so sigma t is the induced tensile stress is equals to p by a. Already we have calculated the formula for the I, just we have to replace the area. Okay, the area is actually 2a into do minus d. So the formula is sigma t is equals to p divided by 2a into do minus d. So you have to put the value of do, d and a and p in this equation. You can get the value of sigma t, where sigma t is the induced tensile stress for the calculated values of do, d and a. If the induced tensile stress is less than permissible, which is given in the problem, then our design will be safe. If suppose induced tensile stress it will exceed the permissible given in tensile stress, then in that case our design will not be safe. Similarly, shear failure of fork. Okay, so here I have shown that after the application of force there is a possibility of failure of fork in shear. Here you can see that I'm going to highlight the portion. So this portion of fork can get tear off. Okay, so we need to calculate the area for this portion. Okay, so here you can see that I have calculated the approximate area. So here the thickness of fork is actually a. For the double fork it will be double I, it will be 2a, and the radius will be do by 2 minus d by 2. So this I have calculated this approximate area from this point to this point. Okay, so this is outer diameter, that is do, that is we need to calculate this area, we need to calculate the radius do by 2 minus d by 2. Okay, so the area is actually tau is equals to P by A is the induced shear stress. Here area is under shear for 1 I of 4 is 2A into bracket do by 2 minus d by 2. Okay, so total area will be A is equals to 2A into do minus d. Okay, so do is the outer diameter, d is the inner diameter, that is diameter of pin, and A is the thickness. Here you can say that A is the thickness of 1I. Okay, so here induced shear stress will be tau is equals to P divided by 2A into do minus d. Okay, so once by using empirical relation, once you have calculated the value for A, do and d, put the values of A, do and d and P, you will get the induced shear stress. Okay, remember one thing, that the induced shear stress it should not be greater than the permissible one. The permissible shear stress is given in the problem, and induced shear stress we have to calculate. If it is less than the permissible one, then our design is safe. If it is going to exceed the permissible shear stress which is given in the problem, then the design will not be safe. Okay, so after the calculation of various dimensions of I and fork by using empirical relation, we have to check the tensile and shear failure of I and fork. We have to check that whether the design is safe in tension and shear or not. Okay, that's it. Thank you. So do watch these two videos of part 1 of design of knuckle joint and part 2 of design of knuckle joint simultaneously for the understanding of design of knuckle joint. Okay, thank you.